In this video, we've got three different absolute value functions that we want to explore. Now, the first one here is f of x equals the absolute value of x. It's just your standard basic absolute value function. I have it graphed over here on the right side, and this is what we're going to compare our other two functions to. So, right here is the formula for just a basic absolute value function. The vertex is going to be h comma k. Okay, that's written right here. And then to graph it, we used a table. I picked a bunch of x values, -2 to +2. I plugged it into my function, so I evaluated my f function for -2, -1, 0, 1, and then 2. And then, took the absolute value of all those x's, and then I got my y's. I plotted those points here. As you see, there's 5 points. And then I connected them all, and then I pointed out my vertex as well. So that's how I came up with just the basic absolute value of x function. So from there, I want to compare my other two. So I have g of x equals the absolute value of x minus 2 plus 3. So let's graph that. Now, if I look at my formula here, my h is going to be what's being subtracted from x. So what number is being subtracted from x? And that's going to actually be a +2. So I'm going to say that h is +2, alright? And then what's being added on the outside of the absolute value? And that looks like it's a 3. So I'm going to say my k is 3. And if you're looking at this, you're like, wait, why? It looks like we're actually subtracting 2. It should be negative, but if I plug all this into the formula, so let's say I write y equals, I'm going to ignore my a, there's no a value here other than 1. I'm going to do the absolute value of x minus, now my h would go right there, close absolute values, plus on the outside is my k. So if I enter in 2 and 3, which is my h, so that's 2, and then my k, which is 3, I'm going to get y equals x minus 2, so that's what's inside my absolute value, and then plus 3. So that's exactly what we have. Now, if I plot this on the graph, I'm going to do my vertex, which is 2, 3, so I shift to my right 2, and then up 3. And there's my vertex. Now, we'll explore a, which is our slope, in other videos, but for now, just assume that the line going up to my right will just be up 1 over 1, up 1 over 1, and then my line going up to the left would be up 1, back 1, up 1, back 1. And then I'll draw these lines, connecting the points. Okay. And that would be my absolute value function. You notice that if it looks like we're subtracting inside the absolute value equations, we're going to go right. We shift right. And then whenever we add on the outside of the absolute values, we're going to shift up. Okay, so you'll notice right here we went to the left, to the right, and then up. And that's that. So let's check out another one. We've got h of x equals the absolute value of x plus 4 minus 1. So we're going to guess what's happening here. In our last one, we subtracted in the inside of the absolute value, so that shifted it to the right. So if we're adding it, it probably is going to shift it to the left. So I'm just going to make this guess here. And then on the last one, we added on the outside, which shifted our graph up, but since we're subtracting, I'm going to just guess that we're going to shift down. So I'm thinking maybe left and then down. So then I follow my formula, right? And I'm saying that 4 is being added to the x, and we want to figure out what our h is. Actually, our h is going to be a -4. And then our k on the outside, it's a little bit easier to see, is going to be -1. And now you're saying, well, wait, it looks like h would be a +4, right? But let's plug all this into my formula again, just like we did in the last problem. Absolute value of x minus our h value plus our k value on the outside. So now, if we're going to assume that this is our vertex, we're going to plug that in. So that is -4, this is -1, and I'm going to simplify things a little bit. So y will equal the absolute value of, when we have x minus a -4, that's the same thing as the absolute value of x plus 4. Close absolute values, and then adding a negative number is just the same thing as subtracting it. So this is exactly what we get up here. So our vertex is confirmed. That's going to be at -4, comma, -1. So if I plot this on my graph, I go to the left 4, 1, 2, 3, 4, and then down 1. Whoops, that should be in blue. And that's going to be my vertex. And then again, we're assuming that the slopes of both of these lines would be up 1 over 1, up 1 over 1, up 1 over 1, and then up 1, back 1. I'll connect these points, and that's what our graph looks like. Right there. Okay, so just like we predicted, whenever we add inside the absolute value bars, we're going to actually move backwards. We're going to go left, however many times. So in this case it was 4. And then whenever we subtract on the outside, we're actually going to shift down. So that's that.